hello, we're going to start Unit 5 where we're going to start graphing and then transforming trig functions, but I'm going to break this up into 5.1 into a couple of parts. So let's go ahead and get started. So when we're talking about graphing the sine and cosine, we'll briefly take a look at tangent. Again, this is going to be because we've lost a few weeks at school and we're really crunched. This is the cliff notes basically. In class you would have seen a lot more examples. Okay, so when we graph this, we're basically looking at taking our function sine of x or cosine of x, just like we would graph a function f of x is equal to something. We're going to have an input and an output, and we'll graph it on an xy coordinate graph here, where this is my independent variable, my input. This is my output right here. Well, my input is going to be my trig functions, and say pi over 6, because we're going to do this in radians. We don't have to, but that's going to be what you're going to see again from algebra 2 and above. You're going to be graphing in radians. So my input, remember, my input is my angle. My output is this y coordinate right here is equal to 1/2. So we would actually go over here at pi over 6 and plot 1/2, and so on. Well, we're not going to plot all these points. We're going to plot just enough to give us a pattern. And that typically is going to be our main points of 0, 45, 90, so on, or 0 or 2 pi, pi over 4, pi over 2, 3 pi over 4, pi, so on. Same thing for our cosine. And we're going to start seeing patterns on this. So let's go ahead and take a look at graphing this. So here we're going to graph sine, and I'll go ahead and do this in blue. All right. And here is my x coordinate, here's my y coordinate, and as you can see, I broke this up into our basic 0 and 45, 90, so on degrees, but in radians. So here we have 0, 0. Then we have pi over 2, pi, 3 pi over 2, and my intermediate ones are going to be my 45 degrees right here. So I can call that pi over 4 if I wanted to. And I can label it right here. It's implied, but we can label it. And I'm going to start inputting my functions. Now I'm avoiding the calculator because it causes all kinds of problems apparently with my computer. So typically we don't have to start at -2 pi, which is the same thing as 0 pi. I like to start at 0 and work my way this way, then I can work backwards. That's a technique, not necessarily mandatory. So if you look at your unit circle at 0 pi, the sine is 0 right here. And we would plot that, and already just did. Now if we were to move over to 45 degrees, which is pi over 4, you're going to find that's root 2 over 2, which simplifies to 0.707. So we went up to about right here to 0.707. And I would kind of plot that point right there, somewhere right around here. Okay? Now I'm on my writing tablet, and it ain't going to look pretty. And it's okay. All right? Then I'm going to go up to pi over 2. You look on your unit circle, and that is going to be a 1. And then we come up to a 1. I'll plot that. Pi over 2, and it's a 1. All right? And it's not a straight line. We're going to have a curve. So let's go ahead and look at what this is right here. That is going to be 3 pi over 4. When you look at that, that's going to be 0.707 again on the unit circle. So let's go ahead and plot that down here. All right, when we get to pi, guess what happens to sine? At pi, sine is 0 again. So let me plot those points real quick. Here I'm at 0.707, and here I'm at 0. So I kind of have this little curve going on. And my writing tablet won't do it justice, and I have an example here shortly of a little better one that I did actually on the smartboard. So coming along, we're going to be at 5 pi over 4, and we just dip down below. We're at now -0.7 because that's negative root 2 over 2. Remember, we're over here on the unit circle. We're in quadrant 2. All right. 3 pi over 2, we just bottomed out, and we're going to be at -1. Then we're going back up again. I could plot that, I guess. So we're at -0.707, which is right about here. All right. Oops, that's not quite 0.707. Let's move that up a little. Move that up a little. Okay, that looks a little better. And let's see, I'm going to be at -1 right here. And guess what? I now may have a pattern where I can just start doing this and plotting there. When I look at my unit circle, sure enough, I have this situation going on here where I have 0. Okay? If I were to start at -2 pi, which is the same thing as 2 pi or 0, I'm going to have 0. All right? 7.7, 0.707, goes up to 1, then it goes back down to 0.707, then it goes down to 0. Then guess what? It's going to go negative. Then it's going to go to -1. Then it's going to bounce back up to -0.707 and back to 0. So what I have here is this really beautiful graph of where I know I'm going to be down here. I'm going to be over here, here. I'm going back up. I'm going to go up over here, all the way up to here to 1. Then I'm going to go back down. I'm going to make it down to 0. Okay? So I have this graph, and here's the hard part for me on the writing tablet. It's going to look really ugly, but you could do a Google search of the sine graph, and you'll come up with it really, really quick. Okay? That's graphing sine. Now, we're going to explore some more in details. We're just getting the graphing down, but I'm going to talk about some other definitions on this as well with a prettier graph. I have that coming up. Cosine. So I'm going to do cosine in green, and if you look on your unit circle, and the cosine at 0 happens to be 1. So in goes a 1 right here. And if I go to 45 degrees, which is pi over 4, take a look at your unit circle, and guess what you have? 0.707. All right? They meet. All right? But this started at 1. This started at 0. Something tells me that this is going to go back down. All right? And it does. At pi over 2, you look at your 90 degrees on your unit circle. Sure enough, we have this. All right? Now, we started up here in green at 1, 0. We dropped down to 0.707, which is somewhere right around in here. All right? Okay. And then we got down to 0. Well, guess what? What's your prediction? We're going to keep on going down. We're going to go down to here, and we're going to go down to here. Let's see if that's true in our unit circle. So when you look at your unit circle, sure enough, at 3 pi over 4, you definitely hit negative 0.707. Where'd it go? It disappeared on me. Well, I typed these out for a reason. Negative 0.707, because I didn't want to be doing this. All right? And it's going to hit -1. And it's going to hit negative 0.707. It seems to meet right here. But here it's going to hit 0. All right? And it's going to hit 0.707. All right? And then it's going to hit 1. There we go. Okay, so how's this graph going to look? Well, we're going to start up here, come down here, back up, hit 0 here, 0.707 here, and we're going to hit 1 right here. It's going to look like this. Really hard for me to do this on this silly little pad of mine. All right? And once you have that pattern down, you can start filling in your points pretty darn quick. All right, and I'm just going and sketching real quick. All right. Oh my goodness, that's just so sad. Alrighty, so let's explore some of these traits. Now, here is a much better picture. So what I have here is I have sine in blue, cosine in green. Take a look at what's going on here. They're actually supposed to meet right here. It didn't quite work out. I start here at 0, 0. I call that starting low. And then I go high. Then I go really low. Start at 0, go high, go low, and then go high again. And it repeats itself. It's like a cycle. We call it circular functions again for a reason, because we're just going right around in a circle. This is like traveling around the circle, and all we did was took some scissors and cut it out and graphed it. The same with the cosine. We started at 1 because my coordinate at 0, pi is 1, 0. And cosine is my x-coordinate. And we just go up and down like this. So this is graphing sine and cosine. You're going to need to practice this a couple of times. All right? So how long to complete one cycle is what we call the period. Now, this is my sine function again. And you notice that I cut out the 45s. I just have my key points right here. Sine starts here. Oops, let's go and make that blue. All right. And at pi over 2, I am at 1. At pi, I'm back down at 0. At 3 pi over 2, I'm at -1 in here. All right. And I could go backwards. Over here, I'm at -1, 0, 1, 0. So I have a beautiful, beautiful sine wave. And anybody who's going to be involved in music is going to get some familiar with some of these waves. All right? Or physics or oceanographers. What all kinds of people do this stuff. Okay? So the period is how long it takes to complete one cycle. Now I've already given you a clue on the circle. One cycle goes from one point to where it completes an entire pattern, circle being 2 pi. This is one period, 2 pi. You go from trough to trough is one way to look at it. Okay? Or you could go from peak to peak. That's another way to look at it. So this is basically one whole cycle. See, if I add 2 pi to this, I'm going to get pi over 2. Amplitude is how high it is from the medium, the equilibrium point. This is a distance of 1, and this is a distance of 1. So your amplitude, and people who measure waves, like oceanographers, will take a good look at this and call that an amplitude of 1. People who do electronic music, we're talking really smart people with computers and all that, get into this stuff as well. Okay, moving on. Cosine, let's see, I didn't have that pre-graphed, silly me. I'll do this in green. So here we're starting low at 0, 0. Well, I call that low. Medium, I'll call that medium, that's better. We start at medium. We're going to go up to 1, down to 0, down to -1, and up to 2. And this is our one cycle right here. All right? And I can continue it like this. And once you get the hang of it, it graphs pretty quick. Okay? So here's my cosine. I started at the medium, and I go up, down, and over. My period is 2 pi. My amplitude is equal to 1, right? Because this is my median. This is my equilibrium line right here. This is like my equilibrium line right here, where I have the same amount above and below. A couple of more tidbits. I just want to show you the tangent. Now, when you look on your unit circle, your tangent is slope, rise over run, sine over cosine, and when you do that and you look at 90 degrees or -90 degrees or however you want to look at it, it's undefined. You can't divide by 0. These are your vertical asymptotes. And you would plot it just the same way. 0, 1, undefined, -1, 0, 1, undefined, so on. You would plot these points and treat it as an asymptote. You would approach with a limit. And you can see the period right here is not 2 pi on this. It's going to be a little different. And you have a domain restriction where x does not equal to pi over 2 over n. All right? So you have it's sort of like a 1 pi period here. All right? But we're not going to do a whole lot with that. So basically, you want to have your sine and cosine functions memorized. It'll come in very, very handy if you do that. So one of the tricks that we teach is if you're doing sine, okay, it's M, I'm in green again, H, M, L, and M. This is medium, high, medium, low, medium. Okay? So I'm going to go up to here and I'm just going to sketch it. I'm going to go up, high, low, and then medium. Okay? Something like that. So you just want to be able to sketch it pretty darn fast. So you have summary is domain is all real numbers. Your range is limited between 1 and -1. Here's -1 down here. Your period is 2 pi, your amplitude is 1, and it's symmetric with the origin. Okay, so that makes it odd. Remember, odd is f of negative x is equal to f of x. All right, so it's symmetric with the origin. Cosine, however, is going to start at high, medium, low, medium, and high. We're going to start up here. We're going to go down. We're going to go way down here, back up, and then back up again. So I'm going to go like this. Oh my goodness, I completely destroyed it. Alrighty, let's try that again. Alrighty. Okay. Not a big fan of this. Okay, we're supposed to be down here, right, at -1. -1 right there. I still missed it. All right, and it curves a little bit right here. Kind of close enough for government work. -1 was supposed to be right here. I'm supposed to hit that spot right there. Okay, so cosine, domain is all real numbers. Range is the same. Period is the same. Amplitude is the same. But here, and we'll explain this possibly in the future, we have this situation. Look on your unit circle, and you can see this very clearly. Cosine of negative x is going to be the same thing as cosine of x. So it's going to be an even function. All right, I think that is it. Yep, I'm going to go ahead and get this done. 17 minutes. It's one of my longer videos, but it is an instructional video, not going over a couple examples.